background. Why is this paper presented? How this paper is actually done? And then I'll talk about a little bit on the literature review on cost management, challenges faced in managing costs, and then BIM. Then I'll go right to cost overruns of iconic buildings around the world. And then I'll talk about BIM capabilities and cost management, and lastly the conclusion. Now, in the recent years, construction projects have evolved to become intricate and difficult to manage due to increasingly and varying demands from the clients for more sophisticated end products at minimum costs and maximum speed. As a global phenomenon, cost overruns in the construction industry is very common, and it is very rare to have projects completed within the budgeted costs. Apparently, there are many previous studies that have actually focused on the significant factors that lead to cost overrun, and some had actually come up with the strategies to overcome the deficiency. Anyway, the issue still persists, and this is due to conventional methods in cost estimation and cost management of construction projects that are based on 2D models, which requires a lot of effort and time from the quantity surveyors because the processes are carried out manually. So way back in 1989, Mitsutaka have actually acknowledged that innovation and advanced technologies potentially increase the competitive advantages within the construction industry by providing the opportunities to lower down the costs. And evolutionary development brought in a remarkable change to the construction industry where building information modeling, or BIM, is currently the most common denomination for a new approach of design, construction, management, and maintenance of buildings. So, why I'm standing here on this topic is because the paper of this presentation is aimed to explore the occurrence of austere errors in terms of costing made in many large-scale projects around the world. And then I would like to review the revolution of cost management process in construction projects with the implementation of building information modeling, or BIM. So how this paper is produced, it's actually through review approach. As I mentioned, it is a conceptual paper. Review approach is adopted via content analysis process. And this review approach is actually categorized or is carried out in two phases. The first phase is to find out the errors in respect to the construction costs existed over several international significant construction projects. And the second phase is to determine the capabilities of BIM in enhancing the process of construction cost management. So a little bit background on cost management. Now, according to the Royal Institute of Chartered Surveyors, cost management is referred to the delivery of best value in building and infrastructure. So to achieve this, responsibilities in managing costs is actually categorized into two main stages. It is pre-contract and post-contract. According to this figure, it is actually the elements of cost management that is exemplified from TOEIC 2013, in which under pre-contract there are cost planning, cost estimating, cost targeting, cost checking, and value management, while under post-contract we have the cash flow process, variations, progress valuation, cost analysis, and at the end, the final accounts. It is noticeable that the process in computing and documenting construction costs are perceived as tedious and susceptible to errors. So the quantity surveyors face challenges in managing costs. After the review of literatures, these are the challenges that are faced by the quantity surveyors. They are prone in managing costs. The challenges are prone to errors, time-consuming. Designs are often too complex, and designers always change designs. And conventional method in managing costs is inefficient, laborious, a lot of errors in specifications, in details, and we have discrepancies in drawings. Designs are fraught with constructability problems, and 2D design is often not tested for functional efficiency against the known elemental costs. So these are the challenges that the quantity surveyors always face in managing costs from pre to post contract. So, what about today's situation? When building information modeling BIM is so oftenly mentioned, what is it about? Now, BIM is the most common denomination for new approach of design, construction, management, and maintenance of buildings. In general, it is not merely a software, but it is both technology and process. According to Ashworth, BIM is able to automate measurement related to the cost management and also facilitate the preparation of accurate estimates. So let's look at this figure, the figure shown on the screen. BIM is actually a tool to facilitate the process in managing, designing data information in digital format, and it also facilitates the life cycle of cost management for a project. So it needs to be distinguished clearly from the traditional computer-aided design that stores and manipulates 2D and 3D geometry. Besides its capabilities in terms of visualization, it has also multi-dimensional capacities such as specialist analysis, detailed design, simulation, 4D. 4D is all about the construction program in terms of timeline, and 5D evaluation of the expenditure in terms of costs. It is a sophisticated technology, however, when collaboration exists among different design partners, exists among all construction players, the costing process will be made easier. And BIM is recently adopted for quite some large famous project. For example, the 2012 Olympic velodrome cycle track at London at the left. And then top right, we have the Walt Disney Concert Hall. Down at the bottom left, we have the Coca-Cola's place at North Sydney. And then bottom right, we have the Miami Science Museum. And in the middle, that's where I work. It is the building of University of Reading, Malaysia. So, let's look at some of the cost overruns projects, iconic projects around us. The first one, let's look at the Port Authority of New York and New Jersey Transportation Hub. It costed USD 4 billion. However, it is twice the original budget. The cost for cost overrun is complicated design. Conceptual design used for early budget estimation was unrealistic because the early design was just a sketch and there's no detail on it. Then we move down to the British Library, which is located just next to the St. Pancras station at London. It costs around £500 million. It is 3 times the original budget. Cost overruns is due to mistakes and delays in information feeding and constant changes to the design. Then move on. We have City of Arts and Sciences Complex in Valencia. Due to low level of details of the designs and minimal degree of precision, it costs around 900 million euro. Almost triple was what originally budgeted, and this also costs a 20-year period of construction. And then move down, we have Constitution Bridge at Venice, a very famous bridge, famous for the bridge design, and also its cost overrun, 200 million euro, 200% of cost overrun. Cost of overrun include absence of timely information because drawings were not supplied promptly, and also the maintenance cost. Even during the construction, they have to replace the material. And then we have the big dig, USD 19.5 billion, cost overruns by 685%. The cost of cost overrun is due to the list of it: incomplete and error-filled designs, failure in identifying errors in drawings, crucial information were not properly disseminated, use of incorrect materials, multitude of interfaces without systematic communication of information, and uncertain construction method, which means these have not been communicated and were not firm during the pre-contract stages. We still have the most iconic landmark in Australia, Sydney Opera House, cost AUD 102 million, cost overruns of 1,350%. The cost overrun causes are minimal technical studies conducted, lack of details in the design. Lastly, we have the Scottish Parliament building at Edinburgh, estimated at £10 million. The final account or the final cost was £410 million. Cost overrun 4,000%. This is due to inadequate specifications on the material and construction methods, and insufficient information such as size, accommodation, and facilities in the drawing. So these cases have actually depicted the erratic estimates exposed project owners to significant risk for the substantially increase of overall costs. However, there are a few academicians or researchers that actually suggested BIM to offer a solution to the deficiency of the issue. So let's move on to see the BIM capabilities and its relevance to cost management. Now, this is a framework for the research, and this framework is developed through a detailed literature review, and the list of literatures are actually stated just right below. The framework is actually developed, and there are four main categories for the BIM capabilities, namely visualization, design, construction, information. But please be noted that these four categories are not standing alone. They are interrelated and interconnected. So, at the top left, we have under visualization. With BIM, we can view drawings from various perspectives in 3D that allows better understanding, and we can have maximum extraction of geometric data. So all relevant information improves understanding on complex designs. Construction method, contract price, quantities, and all required material. So during the design stage, missing items are easily identified. Changes in design specifications is easily identified and presented, and we can actually propose alternative design options with the cost advice. Various design teams can link together with the project elemental areas, which results in an automated update, and clash detection is also permitted. So during the construction stage, BIM encourages collaborations on projects. Changes made on the design will enable all construction players to acknowledge. Contractors are able to receive latest design documents and change order, which incorporate accurate quantities and material specifications. Variations can be calculated quickly. Progress payment calculations can be easier and more transparent, and it also connects and synchronizes the as-built model. So in terms of how information can be sustained within the model or within the system. Cost plans are actually linked to the model to the cost library. Cost information can be integrated with the model and the changes. Information is exchangeable between the construction players. Everything is stored in one location. Awarded contractors' price and rates are in the model, and it is accompanied by a complete construction material specifications. So this is the framework of the paper. So after we have looked into the cost overruns of iconic buildings around the world, and also the BIM capabilities, we now know the issues are poor documentation and communication problems. This issue leads to cost overrun. So accurate and computable nature of BIM enable better performance in estimating and feedback on design changes. So this is a conceptual paper, and a further study or a further paper will be recommended. We will be focusing on the adoption of BIM for cost management purpose in a real-life project as case study. So before I end my presentation, I'd like to show one example. So say, for example, this is a 3D model for a building. This is not any iconic building around the world. It is a new building. Okay, it is just for the purpose of today's presentation. And I'll just like to show you the end product of how BIM can actually lead to the total cost when you are actually looking at the progress or the process of construction. So this is the design building. Okay, so let's say this is, now I'll start with this. When you see these boxes, this is, let's say, the existing structure that we need to take down and demolish. So if you look at the top left, there's this day, week, and total cost. It will run simultaneously when the model is, say this structure is demolished and the new building is being built. And the cost is actually just an assumption, and the building is actually just a design building, a new design building, which is not a commercial building. It is not a registered building. Okay, it's only for this presentation purpose. So, say when we have this substructure going, you will see that the day, the week, and the total cost keeps running. So this is how BIM actually, when you simulate what you have done on the software or on the system, at the end of the day, you can run this and you can show to your client how this can be done. So let's say now, the video has ended. So this building is the same that I showed you just now. Takes 398 days or 57 weeks, and the total cost is shown when it is completed. So if you want to know that, let's say when it is at substructure, you can just stop somewhere and you can see the cost. Or even without playing the video, you can go to the schedule itself to look at it. So everything is within the system or within the process. It is under your control.